In this video, we're going to go over some calculations, and we're going to fill in those calculations in our ANOVA data table. So this is what we're going to need to start with first. We're going to calculate our sums of squares total, sums of squares between, and sums of squares within. This is an important part of conducting an ANOVA. But before we do that, let's take a look and see what each treatment group has in it. So we have 3 different treatment groups, so we're doing an ANOVA, not a t-test. And for each group, we have an N of 10. So there are 10 subjects in each group. And you'll notice on the right, I have notated the capital N for the total N of the study. So between the 3 different groups, there are 30 people in the study. We have next the treatment totals for each individual treatment group. That's with the capital T. And so that is the total of all the scores added together. It's not a count of the scores, that would be the N, but it's the total of the scores. So if I added all the scores for all the subjects together, and we added up with 10 for the first group, 20 is the treatment total for the second group, and 30 is the treatment total for the third group. And then what I have on the right here is G equals 60, because G is the grand total of all the treatment totals. So 30 plus 20 plus 10 equals 60. Finally, at the bottom, you're given the sums of squares within each treatment group. So this is a measure of how much variance there is. If we were to divide it by n minus 1, we'd get the actual variance. But sums of the squares lets us know how much the scores are varying. It's the sum of squared deviations. You didn't have to figure that out. I've just provided those sums of squared deviations here. For treatment group 1, it's 27, group 2 is 16, and group 3 is 23. Finally, there's one other important information we need for sums of squares, and that is the sum of all the squared scores. And you might be saying, well, why do we need that? You might be thinking back to week 4, where we talked about that you have 2 different formulas for finding the sums of squares. You have the definitional formula, which you've all been doing, but there was something called the computational formula too. And in ANOVA, it's easier to use the computational formula. I'm going to go over it with you, so don't worry. But just know that when you're getting everything ready, you also need to take each score, square it, and then sum it up. Now, you don't have the scores here, so you couldn't do that right now. I've provided it for you. In this study, the sum of all the squared scores is 206. We have everything we need here to figure out our sums of squares total, within, and between. First, let's start with sums of squares total. As I mentioned before, we can find sums of squares through either the definitional formula, which you've been using all along, or the computational formula, which is right here. And for this type of problem, it's much easier to use the computational formula. So this sum of the squared scores, I've already given that to you. That was 206, right? Minus our G squared, which is 60 squared for 3,600, divided by our N, which was, our total N was 30. So 3,600 divided by 30 is 120. So 206 minus 120 gives us a total sums of squares of 86. Next, we're going to find our sums of squares within, and that's really pretty easy as well. It involves just taking the individual sums of squares for each group and adding them together. So the sums of squares for our first group was 27, and the sums of squares for our second group was 16. And the sums of squares for the third group was 23. So if we add all of these things together, I have sums of squares within of 66. And finally, for sums of squares between, there is a convoluted formula where you could find that, but we're not going to use that formula. We're going to think about what we know about sums of squares, that the sums of squares total is a matter of sums of squares within plus the sums of squares between. So I can just do a little simple algebra to figure this out. What plus 66 gives me 86? Well, that's 20 right there. 20 plus 66 is 86. So now I have all of my sums of squares that I need for an ANOVA, which is good news because that's 3 out of the 9 calculations that we need to do. So here's our data table, our ANOVA table, and I've went in and added in the sums of squares between treatment, within treatment, and total. Now we need to figure out our degrees of freedom. So we have 3 different formulas for degrees of freedom. The degrees of freedom total are going to be our total n minus 1. Our degrees of freedom within is n minus the number of categories that we have, or we just add up the degrees of freedom for each treatment. And finally, degrees of freedom between is the number of categories or groups that we have minus 1. So for our degrees of freedom total, we have 30 minus 1 because we have 30 total participants, so our degrees of freedom total is 29. For the degrees of freedom within, we just can add up the degrees of freedom for each individual group. So each group had 10 participants. 10 minus 1 is 9. So we can say 9 plus 9 plus 9 is 27. And for degrees of freedom between, we're looking at the number of groups that we have. We have 3 minus 1 is 2. I've added the degrees of freedom into our data table. And what do you notice? Well, the same kind of thing happens with degrees of freedom as sums of squares. If you add up the degrees of freedom between and the degrees of freedom within, they will equal the degrees of freedom total. So there you go. In the next video, we're going to find the mean squares between, the mean squares within, which will give us our F ratio.